Welcome back. In this video, we are going to use the slide method for the least common multiple. Let's begin again with 900 and 360. So we write these at the top. We can see they have a 10 in common, so we write the 10 to the left and divide. When we do, we have 90 and 36. They have a 2 in common. We write a 2 to the left and divide. We're left with 45 and 18. They have a 3 in common. So we write the 3 down and divide. That leaves us with 15 and 6. They also have a 3 in common, and we're left with 5 and 2. They have nothing in common. For the LCM, we actually multiply the entire first column and the bottom row, the leftover at the end. So for this one, our LCM will be 10 times 2 times 3 times 3 times 5 times 2. That actually gives us 1,800. So the LCM of 900 and 360 is 1,800. Now, let's repeat for 1,080 and 1,200. They have a 10 in common. That leaves us with 108 and 120. Those have a 2 in common, which leaves us with 54 and 60. Those have a 2 in common. That leaves us with 27 and 30. These have a 3 in common. That leaves us with 9 and 10, and these have nothing in common. So when we find our LCM, we do the entire first column and the bottom row. So here, our LCM is going to be 10 times 2 times 2 times 3 times 9 times 10, which is 10,800. So this is our LCM for 1,080 and 1,200. Let's use this method once more for 675 and 1,125. These have a 5 in common. That leaves us with 135 and 225. These also have a 5 in common, and that leaves us with 27 and 45. These have a 9 in common, which leaves us with 3 and 5, and 3 and 5 have nothing in common. So for the LCM, we multiply the first column and our bottom row. So our LCM, we have 5 times 5 times 9 times 3 times 5, which is 3,375. So the LCM of 675 and 1,125 will be 3,375. Now, let's connect this to powers and the LCM. Let's consider the numbers 2 to the 6th times 3 to the 4th times 7 cubed, and 2 to the 5th times 3 to the 10th times 7 to the 5th. For the LCM, we use the highest exponent on each prime number. So for the 2, we use the 6 exponent. For the 3, we will use the 10 exponent. And for the 7, we use the 5 exponent. So the LCM here would be 2 to the 6th times 3 to the 10th times 7 to the 5th. Now let's repeat for 2 to the 7th times 3 to the 8th times 5 cubed, and 2 to the 9th times 3 to the 4th times 7. For our LCM, we include every prime that appears in either expression using the highest exponent each time. So for the 2, we will use the 9. For the 3, we use the 8. The highest exponent on the 5 is the 3, and the 7 is a 1, so times 7. So our LCM here would be 2 to the 9th times 3 to the 8th times 5 cubed times 7. This is the perfect counterpart for GCF. For GCF, we use shared primes only and the lowest exponents. For LCM, we use all of the needed primes and the highest exponents. That contrast is worth emphasizing again and again. In the next video, we'll summarize the big ideas and compare these methods.